this is going to give you a brief walkthrough on Lab 8, which focuses on multivariate regression and gives us a little bit of an idea into how omitted variable bias works. So the first thing we're going to do is estimate a baseline regression model, and in this lab walkthrough, I'm just going to focus here on the deficiencies model, right? So I am running the reg command, right, specifying deficiencies as our dependent variable, and government ownership as our main independent variable, right? Which gives us a table that we've seen time and time again throughout this course, right? But as we talked about in our conversation on causality, right, there might be threats to inference such as omitted variables that could be biasing our results, right? In other words, this link between government ownership and deficiencies might not actually be negative 1.6 with a p-value of 0.01, right? There could be something else that is influencing this relationship that's not specified in our model. So what I'm going to do here is then estimate a model that adds several more variables, right? So we're going to add nonprofit ownership to the equation, right? Which means that our government variable is going to be a direct comparison to the private sector, and same thing with the nonprofit. That's also going to be a direct comparison to the private sector. We're also going to account for chain affiliation, hospital affiliation, and total nursing hours per resident day, right? And your final specification doesn't necessarily have to look like this. You can, let theory guide you, or whatever you think is the proper model specification to model these dynamics correctly. So let's go ahead and run this regression. And what we see here, right, is that our relationship between government and deficiencies is basically the same, right? So we see here that relative to the private sector, government ownership is associated with a 1.6 lower deficiency rate, right? And the p-value is about the same. Right, so in this case, we would conclude that there isn't omitted variable bias, right? It seems that there were no confounding factors that, at least insofar as our data set's concerned, we weren't accounting for. So now just for an example, let's run this regression where we look at the percentage of Medicaid residents, right? So again, this is sort of a baseline estimate that we've seen in past weeks. And then when we extend it to the multivariate case, right, we're including a nonprofit dummy variable, the chain dummy variable, the hospital affiliation dummy variable, and the total nursing hours per resident day. And in this case, right, now we see a completely different sign for the government, right? So instead of being associated with a 1% decrease, it's now associated with a 2.5 percentage point increase, right? It's still statistically insignificant, but the effect is much different, right? So in this case, we would conclude that there was an omitted factor or several omitted factors that moderated that relationship between government affiliation and the percentage of Medicaid residents. Right, so now what I want to show is a way that we can go about calculating the substantive significance of our effect size. Right, so I'm going to estimate this deficiency model again. Right, so based on this output, we would interpret this as relative to the private sector. The government sector has 1.6 fewer deficiency points, right? So this is a percentage point difference. But what we want to do is then maybe express this as an actual percent change rather than a percentage point change. And in a lot of ways, that can be a little bit simpler to interpret. So what we're now going to do is estimate, put some descriptive statistics out there. So we're going to summarize the deficiency measure if E sample. So what this is going to give us is the mean value of deficiencies for our model. And then what we're going to do is type dis, which is short for display, and it allows us to use Stata's built-in calculator. And then we're going to copy and paste this coefficient, divide it by the mean and then times 100. And so we get this value of 19.9, or about 20. And what this tells us is that relative to the private sector, the government sector has 20% fewer deficiencies on average, right? Which I think personally is an easier thing to visualize and understand than saying 1.6 percentage points, right? So the substantive effect size is they perform 20% better than the average nursing home. Now, what I want to do is give you guys the tools to produce a coefficient plot, right? And if you haven't installed it already, you'll go ahead and run this command. And then what you do is you estimate the regression, followed by coef plot, and then comma x line 0. And what x line 0 does is it puts a line at 0. And that can be really helpful here because it allows us to tell if our confidence intervals clearly overlap 0 or not, right? So we see here, this is a statistically significant effect, right? This is where 0 is. Our confidence interval doesn't overlap it. Same thing with nonprofit ownership, right? And what this is essentially doing is taking our regression table and instead of showing it in that format, interpreting it as a graph or a figure that might actually be a little bit more intuitive to understand.